Hello, my name is Joshua Maddox. I'm a student in Dr. Soar's Physics 2513, the Physics 1 class on Monday, Wednesday, Friday from 10 o'clock to 10:50. And this is my video project, and I will be discussing projectile motion. In this video, I will go over a couple of examples of projectile motion, and we will discuss how we handle two-dimensional projectile motion mathematically. One of the easiest ways to deal with two-dimensional projectile motion is to just analyze the motion in each direction separately. In other words, we will use one set of equations to describe the horizontal motion of an object, and we'll use another set of equations to describe the vertical motion of an object. By doing this, we will turn a single difficult two-dimensional problem into two simple one-dimensional problems. Like I said earlier, the way we handle and solve for projectile motion problems in two dimensions is by first splitting it up into horizontal direction and motion by using equations such as this, and by splitting up our project into vertical direction or motion and using the kinematic equations shown above. Now, in solving projectile motion problems, we will use any of the following equations, but after analyzing our example, which will be shown on the next slide, we will be able to determine what variables are needed to solve the problem that we are given and what variables are not needed, so we will know which equation to actually use to solve our problem, as we will see in our next slide of our example. Some things to note would be that we are able to split our problem into two separate problems because the change of velocity of an object does not, in the vertical direction, does not affect the horizontal velocity of an object. In the same way, the horizontal velocity does not affect the vertical acceleration of an object, nor does a horizontal velocity affect the vertical acceleration of an object, and vice versa. As we look at our projectile motion example, we will see in this question that a particle has an initial horizontal velocity of 2.5 meters per second and an initial upward velocity of 4.6 meters per second. It is then given a horizontal acceleration of 3 meters per second squared and a downward acceleration of 2.2 meters per second squared. So we will be finding in this example what the speed was after a time of 5.7 seconds. Now, as we said in the last slide, the key to solving a two-dimensional projectile motion problem is to split our question up into two one-dimensional problems and then putting them together and solving using our equations that were given on the last slide. So first, we will start with our projectile motion in the horizontal direction. So we see our equation given is our velocity equals our initial velocity in the x direction plus the acceleration in the x direction times the time. So based on what was given in this question, we see that 2.5 meters per second, which is the initial velocity in the x direction, plus 3.3 meters per second squared, which is the horizontal acceleration, times 5.7 seconds, which is our time, will give us a speed of 19.6 meters per second in the x direction. Now we will do the same for the y direction. We see this equation is the y final velocity is the y initial velocity in the y direction minus the acceleration in the y direction times the time once again. So we will take this equation and we will go back to the question and we will see that 4.6 meters per second, which is the initial upward velocity, minus 2.2 meters per second squared, which is the downward acceleration, and times that by 5.7 seconds once again. And you will see our result is negative 7.94 meters per second, which is the final velocity in the y direction. I do want to point out that this velocity in the y direction is negative. And because it is negative, it's because we are going in a downward acceleration, which means our velocity should be negative. If we were going in the upward direction, our velocity would be positive. We now will put these two equations together, and we will find what the overall speed was after 5.7 seconds. So we will take our velocity, and the equation that we need is the velocity in the x direction squared plus the velocity in the y direction squared, and find the overall square root, and that will give us the time, the velocity after 5.7 seconds. So we will take this equation, enter in our numbers, our 19.6 meters per second squared plus negative 7.94 meters per second squared, take the square root, and we will see that our answer to our problem is 21.1472 meters per second, which is the velocity after 5.7 seconds. We will then look at our part 2 of our question of our example, and we will see what is the direction of the velocity at this time with respect to the horizontal. Our answer will be between negative 180 degrees and positive 180 degrees. We see that our equation given is tan theta of the velocity y over the velocity of x. And we will see that when we find theta, we will need the arctangent of the velocity of y over the velocity of x. So we take what was given in our last problem, the two velocities in the y direction over the velocity in the x direction, and we find the arctan, and we see that the direction of the velocity at this time with respect to the horizontal is once again 21.1472 meters per second. This has been my video on projectile motion, and I hope you enjoyed. Thank you.